Welcome to Algebra 1, Lesson 21 with Miss Barrett. So in today's lesson, we're going to simplify radicals. And what it means to simplify, that's important. Simplifying means to break down into smallest parts. Break down to smallest parts. And that's what we're going to do. We're going to break down big numbers into small parts. Okay, and in this box here are the steps. All right, so the first step is we're going to create a prime factor tree. Okay, and for the numbers under the radical. So for example, we would create a prime factor tree for 100, for 60, for 20, 88, 94, and so on and so forth. Okay, the next thing we're going to do is we're going to continue to break down each number in the tree until all numbers are primes. And a prime number is a number that only has the factors of 1 in itself. So for example, 3, 2, 5, and 7 are all primes. Okay? Once you have all your primes, okay, you're going to take the square root of all the numbers and then place them outside the radical. This is only if you're only going to place the actual answer outside of the radical if it's a perfect square. And I'll show you what I mean in a moment. And then last but not least, take all leftover numbers and put them under a radical. Okay, so that's what we're going to do now. Now, before we start that, I wanted to make sure that we remember some of our most important perfect squares. So for example, 1 squared equals 1. Okay, 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. Okay. 9 squared equals 81. 10 squared equals 100. 11 squared equals 121. 12 squared equals 144. 13 squared equals 169. Okay. 14 squared equals 196. And then 15 squared equals 225. And last but not least, 20 squared equals 400. Okay. So these are some of our most useful perfect squares. And you'll see why in a minute, because it will help us simplify to know the perfect squares. When you take the square root, you're going to get a whole number. And that's the whole number that has to go outside the parentheses. But let me just not tell you, let me show you. So we're going to follow these steps. Now, number 1 is the square root of 100. And that one's fairly easy because 100 is a perfect square. 100 is a perfect square, which means that 10 times 10 equals 100. So therefore the square root of 100 is 10. I think that's one of the most popular and most commonly known square roots. So that one was kind of easy. Now 60 is a little harder. So the first thing we're going to do our prime factor tree of 60. We're going to start with 2 because starting with 1 doesn't matter. 1 is just like a baseline. We know that 1 times 60 is 60. We don't need 1. So, but I also know that 2, which is a prime, times 30 is 60. Okay. Then I could break down 30 into 2 times 15. And then I could break down 15 into 3 times 5. So that's my prime factor tree. As you can see, all I end up with on the ends are prime numbers. So I'm going to write those prime numbers out like this. 2 times 2 times 3 times 5, okay? Okay. Now I have a doubles here. I have doubles here. So saying 2 times 2 is like saying 2 squared, okay, which is like saying 4, okay? So this is basically 4 times 3 times 5, okay? So I'm going to put my square root sign on my numbers. So I have 4 times 3 times 5. Now the square root of 4, if you look over here, the square root of 4 is 2, because 2 squared is 4. So I'm going to take the square root of this by making it a 2. And then I'm going to keep my square root sign with my 3 and my 5 because they are not perfect squares. So I have now broken down 60 into the smallest parts. 60 can be broken down into 2 times the square root of 3 times the square root of 5. All right, now let's look at 20. 20 can be broken down similarly. So 20 is 2 times 10. 10 can be broken down into 2 times 5. And that's it, because all I have left are my primes. So now I'm going to take my primes, I'm going to write them out. 2 times 2 times 5. Okay, write them out as factors. So 2 times 2 times 5 is 20. And if you think about it, it is, because 2 times 2 is 4, 4 times 5 is 20. That's the logic here. Now I have doubles. I have 2 times 2, which is like saying 2 squared times 5. Okay, and 2 squared is 4. So I have the square root of 4 times the square root of 5. 4 is a perfect square. So I'm going to take out that 2 because the square root of 4 is 2. And I'm going to keep my square root of 5 because 5 is not a perfect square. There is no square root of 5. And that's my answer. So the square root of 20 simplified is 2 times the square root of 5. Okay, next up, 88. I'm going to do my factor tree, my prime factor tree. I'm going to start with 2. So 2 times 44 is 88. Okay. And now I'm going to do 44. So 2 times 22 is 44. And 2 times 11 is 22. So now I'm left with all my prime factors. So I'm done with my table, my tree. Now I'm going to write these out. So I have 2 times 2 times 2 times 11. Now what you'll see is I have 3 2's, but I'm not concerned with the third 2. I just want the doubles, because 2 times 2 is 2 squared. And since taking the square root is the opposite, we only want to square the numbers. So I have 2 2's here. That's 2 squared times 2 times 11. 2 squared is 4 times 2 times 11. So I'm going to put my square roots. Okay, because remember, we're dealing with the square root of 88, not just 88. So the square root of 4 times the square root of 2 times the square root of 11 equals the square root of 88. Well, the square root of 4 is 2. I'm still simplifying. And then 2 and 11 are not, either of them are not perfect squares, so you can't take the square root sign away. So it just becomes the square root of 2 times the square root of 2 times the square root of 11. And we have now simplified the square root of 88 into the smallest parts. Bless you. Okay. And mind you guys, if my work is slanted, it's because of the way I have to write. I'm actually filming on a tripod, but I can't like put my hands through it. 94. So we have the square root of 94. Let's start doing that one. So 94, I think we can start with 2. So 94 divided by 2 is 47. Okay, 47 should be able to be broken down into Let's see. What can we divide 30? We can divide 94 by, what else? And you can use your calculator to figure out what you can divide these numbers by, ladies and gentlemen. I'm thinking that 47 might be a prime number. I'm thinking that 47 might be a prime number. I think so. So it looks like 47 is a prime number, which actually does make sense. So once we figure out that 47 is a prime number, the only two numbers we have here are 2 and 47. Now what happens then, when you have that numbers like that, you just say it's 2 times 47, okay, which ends up being the square root of 2 times the square root of 47. And since they can't be broken down any further because they are not perfect squares, neither of them are perfect squares, then this is just your answer. That would just be your answer. Yep, that's it. Okay, so it's not always the case that there's going to be a situation where you can take the square root of a perfect square and put the number outside of the radical. There are going to be situations where your answer will still be two radicals multiplied by each other. Okay, next up, 81, the square root of 81. Well, we could do our prime factorization. Now, I'm sure that you guys have already figured out that the square root of 81 is going to be 9, because 9 squared is 81. But let's see if we were doing it with our prime factorization, if we would get the same answer. So 81 can be broken down into 81 divided by 3, which is 27. And then 27 can be divided by 3 to make 3 times 9, and 9 can be divided into 3 times 3. So here you say we have all threes, which is 3 times 3 times 3 times 3. So we had two sets of doubles here. There's 4 threes, so that means this is 3 squared, and this is 3 squared. So it's 3 squared times 3 squared, which is 9 times 9, or the square root of 9 times the square root of 9. Okay, and the square root of 9 is 3, so it becomes 3 times 3, which is 9. So either way, we came to the answer that the square root of 81 is 9. But we already knew that because that's one of the really popular square roots. Okay. All right, next up, the square root of 250. So 250 can be broken down into 5 times 50, and then 5 times 10, and then 5 times 2. So we have 5 times 5 times 5 times 2. Those are our primes. So 5 times 5 times 5 times 2. Again, we're only concerned with doubles. So we have a triple here. So we only want to concern ourselves with 2 of these 5s. So that's like saying 5 squared. Okay, and then we have this other 5 times 2. Now 5 squared is 25. So I'm going to write my radical sign, because remember, we're dealing with the square root of 250. So these factors have to have square root signs. The square root of 250 times the square root of 5, the square root of 25 times the square root of 5 times the square root of 2. The square root of 25 is 5 times the square root of 5, which is just the square root of 5 because it's not a perfect square, times the square root of 2, which is also not a perfect square. So this is our simplification. The answer is 5 times the square root of 5 times the square root of 2. Now let's do 72. 72 divided by 3 I could have started with 2, but I'm just going to start with 3 just for the sake of time. It's 24. 24 divided by 3 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So here goes all of my primes. 3 times 3 times 2 times 2 times 2. 3 times 3 times 2 times 2 times 2. Now you got to look at all your doubles. Look at all your doubles. We have a double of 3s and a double of 2s. So it's going to be 3 squared times 2 squared times 2, because we can't leave out this 2 right here. Okay, 3 squared is 9, 2 squared is 4, and 2. Put your square root over each of them. The square root of 9 is 3, the square root of 4 is 2, and then we have the square root of 2. This one requires more simplification, because now I have the 3 times 2, which is 6, and times the square root of 2, because 2 is not a perfect square. And last but not least, 950. Now that's a really big number, so it's going to require us to do quite a bit of a factor tree. So 950 can be broken down. Let's start with our first prime number, which is 2. And that's 475. So 2 times 475 is 950. And then we can break down 475 into 5 times 95. And then we could break 95 down into 5 times 19. Okay, 5 times 19. Now, 19 is a prime number, so that's where I stop. And I take all my prime numbers. So I have 2 times 5 times 5 times 19. I have doubles of 5, so it's like saying 2 times 5 squared times 19. All right. 2 times 5 squared is 2 times 25 times 19. Put your square root signs, because remember, we're dealing with the square root of 950, so they all have to have square roots. And then the square root of 2. Okay, the square root of 25 is 5, so I'm going to put that in front of the square root sign, and then times the square root of 19, which is not a perfect square, so there's no answer for that. So the answer to the question, what is the square root of 950? Simplified, well, that's 5 times the square root of 2 times the square root of 19. Okay, so what we did here is we broke all of these numbers down, these square roots, down into smaller parts. Okay, smaller parts. Now, for your practice, you're going to practice doing this with different numbers. It says homework, but of course it's practice. It says simplify each radical. Make sure your answers are in radical form and not in decimal form. Be sure to show all of your work. You may need a calculator when you're going down your prime numbers. Just use a calculator if you need to. This number divided by 2 is what? This number divided by 3 is what? This number divided by 5 is what? Okay? So you're going to do it for all of them. If it's an easy one, I'm kind of giving you the answer to this. If it's the easy one, like the square root of 144, you don't have to do all that. You can just write 12 and I'll be fine. Okay? But there are some bigger numbers here. Remember to go down the prime numbers when you do your prime factor tree. Right? Make sure your answers are in radical form unless there is a perfect square. This is due, or I suggest you do this practice by tomorrow, Tuesday, May the 5th. Have a good day. Bye.